Here's the question. What is a mole? A mole is a measurement used to count very small items. It's like counting in dozens or counting in tens. It's a number. Like a dozen is 12. A mole is a very large number. And I can count 1, 2, 3 dozens. Like I could count 1, 2, 3 moles. A dozen is 12. And a mole is a little bit bigger. Let me explain how big. A mole is a number, but a mole is a fluffy creature. If I had a mole of moles, so instead of like a dozen of moles, I had a mole of moles, and released them onto the Earth's surface, we would all die, because that's how many small furry animals there would be. The moles would cover the entire surface of the Earth. There would be 80 kilometers deep of furry animals. That's where the space begins. So our atmosphere would be completely full of furry moles. That's a mole of moles. It's huge. It's a very, very, very large number. Let's move on to the relative atomic mass. The relative atomic mass is the weight of atoms. Like the name, is the atomic mass of an atom. The problem with the weight of atoms is that it weighs so little that normal measurements don't work. Grams are too big, ounces are too big, kilograms are definitely too big. So another form of measuring was created. This is the relative atomic mass. But what is the exact number of a mole? It is 6.02 times 10 to the power of 23, or written out 602.214.129.0000000000000. That's huge. Why would we ever need to count with such a large number? It's because we have to count very small things. Small things like atoms or molecules. The atoms are so small that we have to count a large number of them so we can actually weigh them. It would be impossible to count atoms singly because they are too small. So to recap, a mole is a number that is huge, is so large so that we can count atoms. The relative atomic mass is a smaller form of measuring. The atom's weight, or atomic mass, is only relative to each other. Hydrogen weighs 1, but relative to other atoms, it does not weigh 1 gram. The RAM is the mass of an atom. The relative molecular mass is the mass of a molecule, and the relative formula mass is the mass of a formula. What is the difference between an atom, a molecule, and a formula? A molecule is composed of different kinds of atoms, so the atomic mass of each is added together. A formula is similar, it just includes ionically bound compounds as well. The mass of oxygen would be the relative atomic mass. The mass of CO2 would be the relative molecular mass. And the mass of pH3 and H2 would be the relative formula mass. There's a way to show the amount of atoms when you react elements. This is a chemical equation. The equation shows the reactants and products. On the left are the reactants, and on the right are the products. The left reacts to make the right. The equation is useful because it shows how much of an atom the reaction should produce. The left and right sides are equal. If there is 10 hydrogen on one side, there must be 10 on the other too. Knowing the amount of one side tells what will be on the other side. This way, the equation is useful to show how much of a substance will be made. The chemical equation has different symbols that represent the atom and the amount of atoms in the equation. Take 2H2O. The H represents hydrogen and the O represents oxygen. Each element has 1 or 2 letters that symbolize that element. The symbols are used in the chemical equation. There's a small number on the bottom right of some element symbols in an equation. This tells how much of that element is bound with the compound. H2O, the small 2, means there are 2 hydrogens bound to 1 oxygen. The big number on the left of some letters indicates how many molecules of all the elements that follow will react. 2H2O means there are 2 molecules of the double hydrogen and oxygen. The 2 molecules are not bound together though. These symbols represent reactions. Chemical equations can show how much of an element there is in an equation. Our problem is, what mass of oxygen is needed to react with 8.5 grams of hydrogen sulfide? We're trying to figure out the grams of oxygen. For this equation, we use the stoichiometric ratio. So what we do is we convert the grams into moles, and then using the stoichiometric ratio, find out how many moles of oxygen we have, then convert that into grams. To find the moles of hydrogen sulfide, we divide the grams by RAM, the relative atomic mass of hydrogen sulfide. And to find the relative atomic mass, we add a hydrogen plus a sulfide, which is this. So 1 plus 1 plus 32, which gives us 34. Divide 8.5 by 34, and we get 0.25. We multiply 0.25 by the stoichiometric ratio, 3 to 2. This is the ratio of this compound to this compound. 2 of this bonds with 3 of this, and that's the stoichiometric ratio. So we multiply it by that, and we get 0.375. Now, to convert, we have 0.25 moles of hydrogen sulfide and 0.375 moles of oxygen. We convert the moles into grams by multiplying the moles by the RAM. To find the moles of oxygen, we have 2 oxygen, so we do 16 plus 16, which is 32. So 0.375 times 32 gives us 12 grams, and that is our answer. 12 grams of oxygen.